Okay, so Git is basically a version controlling system. What that means is like Git is a software which controls the version of your source code. So like I have a version of my software, version 1.0, then I make some changes and release version 2.0, then I keep making changes. So Git handles all that. When we have a big team working on the same software, like 50 people, 100 people, then some people might change something and other person have no idea, and then differences in source code of all the people will make some major conflict. Git basically organize your source code, and if this is the first time you are dealing with Git, then it might be actually really hard to understand at the first time. It takes some time to get that understanding, but once you get used to it, then this will become the most productive software in your day-to-day life. And of course, you cannot work in any technical industry without knowing Git. You have to work on Git, no matter you are web developer, app developer, or any any technology you are working on. You must know Git first. So you must understand how technology works. And in case of Git, the technology behind Git is incredible. Actually, how that works is you must know that how exactly it stores the files. So it uses this simple key value pair system. We have key and value. If you are coming from Python, then you know dictionaries where we have key and value. So key is to identify our value. So like I have username as key, value will be my name. So in case of Git, value is actually our data, the data we want to store. In most of the cases, that is our source code, and the key is the hash of that data. What exactly is hash function? It will analyze our data and give us a fixed size string which will represent our data, and the hash function is not reversible, so you cannot have like hash function and you can get the data back. It's not possible. So just to get good understanding of this, assume like if we have a data of 100 lines of code, and if I generate a hash, it will give me a 256 character of string, which will be very unique and random. And now if I change even a single bit, even just a space in all these 100 lines, then the hash will be changed and it will be completely unique, completely new, complete randomized. So you cannot predict what hash will be generated and you cannot get your data back from that hash. But if I don't change the data, then the hash will be same. So if I have two source code and I want to check if both source code are exactly same or not, then I just generate their hash and compare them. If both hash are exactly same, then the source code will be same. So I just said that hash string will be 256 character, but in case of Git, it's actually 40 characters. There are different hash functions from really simple to really complex. The hash function which gets used very often is called SHA-256. You might have heard about cryptocurrency. Bitcoin actually use SHA-256, but in case of Git, we use SHA-1, which is actually 40 characters of string. So developer just decided to go with SHA-1 and it's 40 characters string. So it's cryptographic hash function, and so basically concept is same. If we given a piece of data, it produces a 40 digit hexadecimal number. So number will be like the hash will be AB93, and this type of long string of 40 characters, simple. And the value will always be same if the given input is same. Okay, so this is all about the key. Until now we just have covered this part. This is all about key and hash function. What about the value? How it stores our data, our exact source code? Git uses something called Blob. Blob stores our exact source code but in compressed manner, and with the compressed data it also adds some metadata with it. Like if I have any folder, if I go to like this IG content folder and if I check for properties, and this is all metadata about what is the file name and its size and when this was created. This is all metadata, and Git stores that metadata into blob. Basically identifier of our value is blob, and it stores the size of the content and some delimiters. Delimiters is like, if you have seen and work with Excel sheet or something, there are files with extension .csv or something. In files like CSV, all the contents will be separated by comma or some kind of delimiter, and in the case of IP address the content will be separated by colon. So this colon or this comma is our delimiter. So this type of separators are called delimiter. In case of Git, the delimiter is null character, which is slash, and that is the delimiter which is used with the value in Git. And of course our content. So this is all information blob stores. So if I generate hash for like content like ABC, so when hash gets generated, some metadata will be added with this string. So the metadata will be type of the data structure, so which is blob in this case, then space, and then size of our content in bytes. And in case of this example, size is 3 bytes, so 3, and delimiter null character, and then our content ABC, A, B, and C. So hash will not be generated exactly of this string but of this complete string with metadata, and that hash is SHA-1 function. So let's try to generate simple hash like this so we get a rough idea what I'm talking about. So I'm using a terminal, online terminal from CS50. This is nothing, just basic Linux. So Git is installed in this system, and you can try all of this command I'm trying to do on your own terminal. If Git is not installed, then install the Git. And if you are a Linux, then some of this tool might already be installed, and I will be using Python to generate SHA-1 hash. You can use any other function. There are some other function as well. For example, if I remember correctly, there is something called OpenSSL. You can use this to generate your hash, and you can use online SHA-1 hash generator as well. So this is our string, and we want to get SHA-1 hash of this string. So I'm using echo. Echo does nothing, just print the same string back. Echo added a new line at the end of our string, but when I use /n, echo did not added any line or anything, just printed exact string like that. So I don't want to add any extra character in this, so I will be including /n, so it just print out my data. So let's use /n string. String with hyphen and y. I'm keep saying /n, it's hyphen n switch. And I'm using a git function. If you have installed git, then you will have access to this. Git hash objects actually expects a file, but I will be providing my input from terminal. So I'm using, sorry, I have done something wrong. So my input will be coming from terminal, so I have to use this standard in. So standard input stdin. So this is our hash. Just remember this if you can. You don't have to actually. So this is the hash we get from git. Now I'm trying to generate hash by myself, and I will be including metadata manually, and then try to compare if we get the same hash. So we are just thinking about we are just saying that this all metadata will be added to our string, but we are not sure. So just for the confirmation I'm doing this. So if you are not familiar with Python, then that won't be any issue still, because Python is really simple language and you can read it like you read in English, so you will get most of the things I'm trying to do here. So just first declare our data, which is my channel name. And so one thing here to notice is that we cannot use row string with the function I will be using. So the function I'm trying to use in Python actually expect encoded data, so I cannot use row string, so I'm encoding it in UTF-8. This is just a format of encoding. UTF-8 is not the encoding which get used for Git, because if I have some alphanumeric character between our string or data, then this will fail. But now I just have simple characters, so I'm using UTF-8, and which will work fine in this example. So I need some libraries. I need hash SHA-1 function. Okay, so I'm trying to generate SHA-1 of this data. If I do data here and s dot hex digest, this will generate SHA-1 of our data. And as you can see, both SHA-1, both hash are different. Why is that? I have already explained it. Because when Git generate the SHA-1, it includes some metadata, but when we are generating SHA-1, there is no metadata. This is just a raw string. So let's try to generate hash function with metadata. What will be the metadata? I have already explained it. We have to write blob, the type of our data structure, and the size of our data, and a null character. So size of our content is, I think, 17 characters or something. I have to count the spaces as well. So let's write metadata and 17 characters and a null character. So now our data also have metadata, and now I try to generate SHA-1 again. So this time, if you can see, so this time we get this exact same SHA-1 as before. So now it's confirmed that this is the metadata which gets included with every blob. So this is the structure of our metadata, blob, and the space and size of data, and then a null character and data itself. So yeah, that's pretty much it about blob. Okay, so all this makes sense now, but where does exactly Git store all of these blobs and data? So let's try to analyze that as well. So I just created a Git practice folder, which is empty now. Now I go to the folder. Now I have to tell the Git that this will be the folder where I will do my work. This will be the folder where you have to manage my source code. To do that, I have to initialize a Git project here. So I just do git init, and it says initialize empty Git repository. So now this is Git repository, but if I do ls, the list of files in this folder, it is empty, but it's not actually. So this fancy command is just to open my file explorer, and if I see here, this is empty, but I have this .git directory which is hidden by default because the directory name start with dot. And when I go into this folder, I see a lot of folders and files. So this is where Git stores information about everything. If I delete this folder, then all of the data which Git manages will be deleted. So never do that. So still, where exactly Git store the information and the source code? Let's generate and try to find out by ourselves by exploring. And Yeah, I will be doing the same thing I did before. So this is the same command I just used to generate the hash function, the SHA-1 hash, but this time I will be using hyphen w here. So what hyphen w switch does is that it will write that object as well. It means just if I create a file and save this into this directory, that will do the same job. And I'm doing that, and this is my hash. This is the hash of this string. If you see this hash is different while my string is same. This should not happen, but there is some technical thing that I'm not understanding completely. That's why I did the explanation part on Linux system. But still, where does this information getting stored? I want to find that out. So if I do tree here, tree is command with just tree command is used to just print out the information in just tree format, the files and all of the directories in this current folder. So there are no subfolders because there are none. But if I do tree.git in folder, I see hooks, info, objects, and references, heads. All of these folders are important, but just for now ignore all the folders. But if you have noticed, our hash function is started from 36, and in objects we have a folder 36. This is the folder where this data gets stored. If I go into this folder, there will be a file with the name start from third character till the end. So Git does not actually store all the file directly into a folder and dump them into the folder. What Git actually does is that it will make a folder with the name of the first two characters of the hash function, and all the files which starts from those two characters will be stored inside that. So that is just a optimization strategy Git uses. So now we know where Git store the data. So if you still want to see that, we can go there and see this by ourselves. We go to object, and there is a folder with name 36. I go into this, and you can see A9 up to C, and this is the same hash function as this A9 up to 6. Why it's not highlighted? A9 up to 6. Yes. So yeah, there is where all of our blobs get stored. So this is where all of our blobs get stored, but there is still something missing. Like, this was just a random string we generated, but if there was source code, if I have created a file and there was my Python code written in it and I saved it, some critical information here is missing. Where is our file name? If we have seen our metadata just include blob, a space, and the number of bytes in our data, but file name is still missing. The directory structure is missing. So where all of this information? So what Git use is called tree structure. Git has all the data in a tree format. So in tree format, where we have a root tree, and then root has pointers to blobs and other trees. So, and metadata will include type of the pointer, like if it is a blob or it is a tree, and file name and directory name, and the mode as well, if it executable or not. So this is important. Like if I created a file and it has permission of executable on my system, and I push this repository on remote server, and someone clone that repository to their local system, the permission will remain same. If a file have executable permission on my system, that file will have executable permission on every system which will clone that repo on their local system. So there are a lot of other optimization Git does as well. For example, in tree structure, if we have like two files with the same data, Git will not store both of that files. So if I have a folder A and a folder B, so just assume I have a folder A and folder B. In the folder A I have a.txt, which have nothing, just written hello world in this. So I have, for example, just say I have abc in this, and in B I have another file b.txt. The content of this file is same, again abc. So Git will not store this file individually. What Git will do is that it will just have one copy of that file and reference both pointers to the same file. And that is the exact reason why Git is fast. For example, you have a repo on your local system, and when you switch the branch, all the contents of the branch change in just a second, in less than a second. And if you try to check the size of your branch, it will be more than 100 MB. In if the project is big, then it will be more than that. But when you try to move 100 megabytes from one folder to another, even if you are on SSD, that will still take some time. Why Git is able to do that really quickly running on the same hardware? The reason is same. Git actually is not moving something or changing something. Git just changing the references and the pointers to the data it is pointing to, and data will be changed in exact time. And there are some other optimizations as well. So for example, all Git objects are compressed, and if the file gets changes, that Git will not store two versions of the same file. For example, I have 100 line of code, and I have saved it in after that. If for example I have 100 line of code, and I make a single change in that, Git will not store a complete file with new changes, and have Git must have a history of the previous file, but Git will not store a complete new file with the new changes. Git will just store the changes we have made. What I'm trying to say here is Git will make a file which is called a peg file, and peg file will just store the differences between one version of the file and the next. So Git will not store complete new version of that new file, it will just store those changes. So that is really big optimization. This peg file can also have objects and deltas. Peg files are generated when we do like any git commit or push, and there are too many objects, then Git will create a peg file. And it even shows that in the command prompt. We can see that when we do git push or git commit, there are sometimes it shows that creating or initializing peg files. So yeah, that is the big optimization Git do. Yeah, that is all for this video, and I will be talking about other topics like Git and Git internals and Git remote from next topic. So if you haven't subscribed yet, please check out the channel's other video, and if you like the content, do subscribe. I will be putting more videos like this.